Now, in the previous two examples, you may have noticed that when we changed the angle and we changed the perspective of what's considered opposite and adjacent, that we ended up where sine of one angle was equal to cosine of another, and vice versa. Since the sum of any three angles in a triangle is 180, and angle C is always 90 degrees, angles A and B have to be complementary. Therefore, they have to add up to 90 degrees. We can rewrite this equation, for example, subtracting one of the angles from 90 degrees in order to isolate it. And by taking this relationship where we saw that sine of an angle equals cosine of the other, we can replace the other angle with this expression, where B equals 90 minus A, giving us that sine of A is equivalent to cosine of 90 minus A. That gives us all of our cofunction identities. Sine of an angle is equal to cosine of 90 minus that angle. The same is true for cosine and sine, and for every other cofunction relationship, cotangent and tangent, and secant and cosecant. That's why we call them cofunctions, sine and cosine, tangent and cotangent, secant and cosecant. So we'll be able to do a lot of things with this relationship where we can use the cofunctions. One thing that we can do is write it in terms of its cofunction. Cosine's cofunction is sine. We can rewrite this as sine of 90 minus the angle that's given. So then we have sine of 38 degrees. Cosine of 52 degrees is equivalent to sine of 38 degrees. Tangent's cofunction is cotangent. Cotangent of 90 minus 71. Tangent of 71 equals cotangent of 19. Secant of 24, its cofunction is cosecant of 90 minus 24. So secant of 24 equals cosecant of 69 degrees, or 66 degrees. Now, if we have these equations where cosine of some angle equals sine of another angle, in order for this equation to hold true, in order for cosine of something to equal sine of something, if we consider the relationship up here, cosine of something has to equal sine of something, then we know that A and B have to be complementary. So we can take the two angles, theta plus 4, and we can add them together to 3 theta plus 2, and since they're complementary, they have to add up to 90 degrees. So we can combine like terms. I have 4 theta plus 6 equals 90. Subtract 6 from both sides, we get 84. Theta has to equal 21 degrees. And we can check it by plugging theta back into these equations. Cosine of 21 plus 4 has to equal sine of 3 times 21 plus 2. And these two angles have to be complementary. So we have cosine of 25 has to equal sine of 65. And that holds true with our cofunction relationships. 25 plus 65 is 90. They're complementary. Those two values are equivalent, so we know that theta is equal to 21. This holds true for any cofunction relationship. 2 theta minus 18 plus theta plus 18 has to equal 90 degrees because tangent and cotangent are cofunctions. We combine like terms. 3 theta equals 90. Theta equals 30 degrees.